Hi folks, what I'm showing you here is a Sylvania urban street light from Melbourne, Australia. This is a fairly new light in that they're the current model that are currently being rolled out across the state. What I'm going to show you here is basically the internal workings of the lamp and some of the features of the lamp, and then actually show you the lamp turning on. Now this lamp, if you like, is the successor to the Sylvania B222-4, which I have sitting right there. Now this lamp is an 80 watt Mercury Vapour Street lamp, and as you can see, it has what looks like a flower pot for a diffuser. That's the actual housing there that you can see. Internal control gear is inside here, and the lamp is in a vertical burn position, and the light is on a spigot from the pole, which takes an outer dimension of 34mm spigot. The receptacle that you see here is for the photocell. It takes what's called a D2 photocell, which is this little device here, which looks very similar in some regards to a fluorescent starter. This is the side where the light comes through. It's a cadmium sulfide daylight switch. This is actually made by iLighting in Japan. I'm not sure that you can actually get a good look at the reading. 240 volts, 3 amps daylight switch, and it just goes into this slot. Can only go in the one way, so it just sits into this slot, and if you haven't got it in the right way, it won't obviously click into place, but it turns in like a fluorescent starter, and it just sits in there like that. It's got a little shade here to shade it from the actual lamp, or the light output from the lamp when it's on. So I'll take that out of there because that I'll use later on. So this is the old street lights which are now being replaced. They've been around about 20 years. They came in the 80s and 90s through the noughties, and now they're currently being replaced with this model, which is the Sylvania Urban. Now that little daylight switch that I had is in a similar position to the B222-4, and that just sits in there like that and locks into place. Now this lamp is actually very unique, and I think it's a very good design. I'll show you the other side of it. It has, there we are there, that's the top of the reflector housing, and also where the control gear is housed underneath my hand there. But that black polyurethane cover is kept in place by 4 spring-loaded clips here, which I'm just undoing, and they're retained within the housing even after they've been released. So that will now allow me to flip the lamp over, and I will be able to expose the control gear that is housed underneath. And it just slides off like that. Now this is a used lamp. I actually picked this up from the power company. Believe it or not, it was in the skip bin to be crushed and recycled. So it was in place somewhere out in the streets, so hence some of the marks that you can see. In fact, some of the surface corrosion that's taken place on the choke, or the ballast, if you like. But basically, very simple wiring. It's a Mercury Vapour 80 watt, 240 volt, 50 hertz ballast, and that's it there, sitting in position. I'll get a closer view of that, and you might be able to read some of the info that's on there. Made by Atco here in Australia. This is the photocell receptacle. This is the terminal block, obviously, from where the mains wire comes in, and you can see that just there. And we use the international code for electrical cable colours. And then it obviously works through to the lamp, through into the reflector housing, and then of course the lamp itself. It's a die-cast aluminium, high pressure pressed die-cast aluminium housing with internal control gear. Now this lamp can also house a sodium vapor metal halide control gear, and that is actually mounted on a gear tray that can be just slotted into here and held in place and then put over with the cover. In here you can see where the spigot mounts, and the bolts just close down, clamp down on that. There's actually a locking nut for both of those, as you can see, once it's locked in position. So I'll put the cover back on, and we'll flip the lamp over so that I can show you the reflector housing and so on. And those clips just push back into place, like so. And that will hold the cover back in place for the lamp. I'll just flip that over now. The diffuser is acrylic, held in place by 3 stainless steel clips at either end, and this one which is hinged at the top, which allows the reflector to stay permanently attached to the lamp so that it can be serviced whilst in use. Has a rubber or a silicone seal around the actual acrylic housing. As you can see, that white seal there, that's the silicone seal. The reflector is basically a painted reflector, just painted white. The 80 watt globe, which I'll just unscrew very quickly, it uses what we call an ES27 base, or what you would commonly call a medium base in the United States. It's a Sylvania 80 watt Mercury Vapour bulb, and it's brand new. The internal, or inside the reflector, we have these aluminium reflectors which are screwed into place on either side of the lamp and reflect light out through the acrylic diffuser. We have the E27 socket, which is a screw socket, and that's held in place and mounted onto this plate here, and the cable that comes through from the control gear section into the socket. I'll put the lamp back, and that's the basic configuration of this 80 watt Mercury Vapour lamp, and these are very common all around the state here in and all over Australia. Just lock those clamps down. Alright, we'll turn this lamp on. We'll give you a quick run through on the lamp itself as it turns on. It's a coated bulb. I'll take the photocell socket out of there because otherwise it'll turn the lamp off. As I said, it's a coated bulb, so the Mercury Vapour bulb actually lights up as a very pink reddish colour at initial startup, and that's because of the light correction factor with the phosphors that is used. It's to convert some of that greenish blue light into more red in the spectrum, and that's why the Mercury Vapour bulb is coated with phosphor. It's warming up. It looks quite white on the video, but there's still quite a bit of pink. You can definitely make out the reddy pink colour in the globe in real life as it warms up. It's a very, very bright light. I guess the limiting factor with Mercury Vapour is as they get older, the lamp tends to diminish in its light output depending on use. But on average, I believe it diminishes by around about 20 or 25% every 4 years. So by the time 4 years has come around, it's lost quite a bit of light, or it might be over every 12 months, in which case every 4 years is when the bulb should be changed, which is quite a reduction in light intensity and output over the life of the lamp. I remember having one of these bulbs, and it must have been at least 20 years old.